All right, welcome to a high-speed tour of the Go programming language. We're going to cover the entire journey here, from its core philosophy all the way to building some serious, production-ready systems. So let's get right into it.
I just love this quote because it absolutely nails Go's entire reason for being. It's designed to live right in that perfect sweet spot, giving you that raw, close to the metal speed of a systems language, but with the clean, easy to read vibe of a modern scripting language.
To really get Go, you have to start with its core ideas. This isn't just about learning syntax, it's about adopting a whole new mindset for how you build software. Okay, let's break that down real quick. Compiled just means your code gets crunched down into a single lean file that just runs. That's where all that speed comes from. And statically typed, well, think of it like having a super intelligent spell checker that catches a whole category of bugs before your code even has a chance to run. It is an absolute lifesaver. And all these principles, they just work together so well. The clean syntax and crazy fast compilation time, that creates this amazing feedback loop when you're coding. The batteries included standard library means you can build a ton of stuff right out of the box. Garbage collection handles memory for you, so you don't have to worry. And that built-in concurrency, well, that's Go's superpower. We're definitely getting to that. So with that philosophy in mind, let's look at the actual building blocks of the language, the basic syntax and logic. Think of these as the fundamental rules of the road for our entire Go journey. This right here is a simple little idea that wipes out an entire class of bugs. See, in a lot of languages, if you create a variable but don't give it a value, it's just filled with random garbage from memory. Go says, nope, every variable starts in a known, predictable zero state. It's a simple, powerful safety net that's just built right in. This is a really crucial difference in Go. An array's length is fixed. It's part of its type. When you pass it to a function, you make a full copy. It's like photocopying an entire book. Slices, on the other hand, which you will use 99% of the time, are flexible. They're like a lightweight pointer to an underlying array. It's more like sharing a link to the book, way more efficient. Here is that famous Go minimalism in action. Forget about having while, do while, for each. Go just has one loop, for. And what you see here is its first form, the classic counter loop that you'd recognize from pretty much any C-style language. But here's the cool part. That single for keyword is a total chameleon. If you just drop the setup and the increment part, suddenly your for loop acts exactly like a while loop. It just keeps running as long as a condition is true. See? One tool, many jobs. And finally, here's its most powerful and honestly its most common form. By using the range keyword, it becomes the perfect tool for iterating over collections, like slices, maps, or even strings. It's just another perfect example of that core philosophy. Why clutter the language with 4 different tools when one perfectly designed tool can do the job? Okay, so we've covered the basic logic. Now let's get into how Go builds more complex structures and defines their behavior. And this is where Go takes a really sharp turn away from what you might be used to in traditional object-oriented programming. It's just pure magic in Go. You never have to write my class implements this interface. Instead, you just define an interface as a sort of contract for behavior. And if your type happens to have the right methods to fulfill that contract, well then it just does, automatically. No paperwork required. It makes for incredibly flexible and clean code. You know that annoying thing where you have to write 2 almost identical functions, one for integers and another one for floats? Well, generics solve that. Now you can write a single reusable function that works with multiple types. You get to eliminate all that repetitive code without giving up any of Go's famous type safety. It's all about writing smarter, not more. All right, let's get to the main event. We've arrived at the feature that Go is most famous for. And it's really not an exaggeration to call it the language's superpower, especially for all the modern multi-core computers we use today. So what even is a Go routine? It's really just a function that's running at the same time as other code, but here's the critical part. They are ridiculously cheap and lightweight. They start with just a few kilobytes of memory and are managed by the Go runtime, not the operating system. What that means is you can spin up literally millions of them without your computer even breaking a sweat. This is the absolute mantra of Go concurrency. The old way of doing things is to have multiple threads all trying to access and change the same piece of memory, using complex locks to avoid causing chaos.
Go just flips that whole idea on its head. It says, hey, instead of fighting over the same data, why don't you just safely pass messages to each other? And this is exactly how they do it. Channels are basically the conveyor belts between your Go routines. One Go routine puts a piece of data onto the channel, and another one takes it off on the other end. The channel itself guarantees that only one Go routine is touching that data at any given time. It makes concurrent code safe by design. So we've seen that Go is fast and it handles concurrency beautifully. But how does it actually help you build reliable, real-world applications? Well, the answer is in its incredible production-ready toolkit, which we can kind of picture as a pyramid of confidence. It all starts with a solid foundation of core commands, things like go run and go build. The next layer up adds automated quality checks like go FMT, which keeps your code style consistent. Above that, you get even smarter with advanced linters that find potential bugs before you even compile. And right at the very top, you have built-in security scanning. Each layer just systematically builds more and more confidence right into your workflow. This slide shows off Go's incredibly practical approach to handling errors. Instead of things just blowing up with hidden try-catch blocks, in Go, if a function might fail, it just returns an error value. And the language forces you to check for that error right away. It makes the code flow super predictable and just gets rid of a whole class of bugs from unexpected explosions in your code. This just brilliantly illustrates Go's focus on stability. See, most package managers just go out and grab the newest version of a library, which sounds good, but it can unexpectedly break your code. Go's minimal version selection does the complete opposite. It finds the oldest possible version of a dependency that still works for everything in your project. It sounds a little weird, but it makes your builds incredibly stable and repeatable. And this is the killer feature of Go's built-in security scanner. It's so smart. It doesn't just drown you in a giant scary list of every possible vulnerability in your dependencies. It actually analyzes your code to see which of those vulnerabilities you are actually calling. It cuts right through the noise and lets you focus only on the threats that are real. And now we can just zoom out and see the entire Go landscape. We started with that core philosophy of simplicity. Then we moved to the language's building blocks and data structures. We saw how Go defines behavior. We unlocked its concurrency superpower. And we finished with that amazing production-ready toolkit. You can see how it's all connected in one continuous, logical path. Because ultimately, understanding Go isn't just about learning syntax. It's about adopting a philosophy of simplicity, clarity, and concurrency. And I guarantee it will fundamentally change how you approach building software. So that's our fast-forward tour. I really hope this gives you a solid map for your own journey into Go.